All right, hello everyone. Let's go ahead and get started, please. I hope everybody is doing well today. Hope you all had a great weekend. I don't think there's any surprises about what we're going to be talking about today, what we're going to be getting ready for today. But I do want to take a quick moment to discuss this week's schedule a little bit since it is a little different. We do have the exam coming up on Thursday. We're going to spend a lot of time talking about the exam today in just a few moments. But I do want to bring your attention to the fact that there is no studio this week. So we will not be taking attendance on Wednesday in your lab sections. So there's no activity for you to do in class on Wednesday. Do with that information what you will. There is an assignment due on Wednesday in your lab section. So if you would like to turn that assignment in, the TAs will be there on Wednesday so that you can turn your assignment in. The TAs will also be able to help you answer exam questions and go over exam problems in the labs on Wednesday if that's something that you would like to do. So the TAs will be around. I'll be around, probably printing exams, hopefully by that point in time. Just be aware of what's on the schedule. Also, just want to remind you all that if you would like to turn in your assignment during office hours, you can definitely turn in your assignment during TA office hours. So if you turn in the assignment in office hours and then you don't have any exam questions for Thursday, maybe I'll see you Wednesday, maybe I won't. That's a decision for you to make. But just want to make sure everybody is aware of what's coming up this week. Any questions about the logistics before we hop into exam stuff? Any questions about schedule before we hop into exam stuff? All right, great. Let's have a chat about the exam. The way this is going to work, I'm going to spend, it's not going to take me that much time to kind of go over the, sort of the high-level basics of the exam, maybe do a brief review of the kinds of things that you might expect to see on the exam, but then the rest of the time is going to be open for you to ask questions, for me to go through as many review problems as we possibly have time for. But let me first spend a few minutes just talking about what to expect. When you show up on Thursday, or actually, first off, what to expect to be on this exam. It's the first exam, so it's pretty straightforward. It's going to be over modules 1, 2, and 3. So anything that we've covered up until this point in the class, including the array stuff that we just did last week, is fair game to be on this exam. You do need to bring your ID card. You should bring something to write with, preferably pencils. I know some people like to use pen, but I think pencil's probably a better idea in my opinion, but you do you. And then you also are allowed to bring one sheet of paper with notes on it. I get a lot of questions about this, so just to kind of clarify some rules about this sheet of paper. It is one regular size sheet of paper, right? One sheet of notebook paper, one sheet of printer paper. I'm not going to walk around with a ruler and measure your sheet of paper and make sure that it's accurate to the ½ inch or whatever. That's not a thing. If you come in and you have a sheet of paper that is the size of this desk, then we're going to have a conversation about that, right? I definitely don't want to see something like that, but don't worry too much about the dimensions of the sheet of paper. If it's a regular sheet of notebook paper, regular sheet of printer paper, then you're good. You can put notes on the front and the back if you want to. They can be typed. They can be handwritten if you want to. That's totally your decision to make. The one rule that I have about the content of the sheet of paper is if I'm walking up and down during the exam, before the exam starts, which I will be doing, I should be able to pick up your sheet of paper and I should be able to see what's on it, be able to tell what's on it without having to use 3D glasses or a microscope, right? I should be able to pick up your sheet of paper during the exam and tell what's on it without having to use any additional, eyesight aids or anything like that. So don't try and do anything weird. Don't try and do anything fancy. But do spend some time thinking about what you want to put on that sheet. I think it's actually a great tool for studying. A lot of students find that the stuff they put on the sheet ends up not being the stuff they need on the exam because they studied it so well, right? So that's kind of a good thing. That's kind of a good prep. And then some other logistic things. You do not need any electronics for this exam. People ask me if they can bring a calculator. You can bring one, but you can't use it. So you cannot use a calculator on this exam. I do realize that we do some arithmetic kinds of things in this class. Any sort of arithmetic you have to do on the exam will be simple enough that you can do either in your head or off on the margins to the side. It is not going to be complex math on this exam. Definitely not going to have you taking weird square roots or anything like that. It will all be very straightforward math. This isn't a math exam, this is a computer science exam. So all the math, all the arithmetic is going to be kept simple. You do not need a calculator of any sort. No electronics of any kind are going to be allowed on the exam. And then finally, where to take the exam. First off, if you have accommodations, hopefully you've already set up a time to take the exam with Disability Resources. If not, definitely reach out to them as soon as possible. Have a chat with me after class so we can get that taken care of. For anybody else who does not have accommodations, you're assigned a room based on the last 3 digits of your student ID number. So I just posted these room assignments this morning. Brown 118, Wilson 214, and Louderman 458 are the 3 rooms that we'll be having the exam in on Thursday. I would really suggest you know where you're going before 6:29 p.m. on Thursday. I definitely have had students email me at that late moment, say, "Hey, where's this room?" I'm not going to be checking my email at that moment in time. I can tell you I'm probably going to be in one of the exam rooms getting the exam started, right? So definitely take a few minutes sometime in the next couple days. If you don't know where these rooms are, make sure you know where they are before the exam so you know where you're headed. And I'm trying to think of what else. Oh yeah, let's talk general exam strategy and what's going to be on the exam. So obviously I already mentioned it's going to cover modules 1 through 3. I did post a ton of materials for you to review in order to get prepped for the exam. So I'm referring to this practice quiz, the Past 1 exam questions. Those are going to be multiple choice, fill in the blank style questions, and then this exam 1 coding prep repository, which is going to have code reading and code writing styles of questions on the exam. I want to remind you all that these are all questions that have been on the exams in the past. Also, the quizzes you've been taking, actually these are the same questions. The quizzes you've been taking are from this Past 1 exam questions practice quiz. You've been taking exam practice questions every week when you take the quizzes already. Those are all past questions that have been on the exam. People ask me if they can use the quizzes to review. Absolutely, you can, but keep in mind this is sort of a big list of all the quiz questions, so it's the same thing. You're not going to find any different questions on the quiz that you won't find on the practice exam. As far as the type of questions you're going to see on the exam itself, one question that I get asked a lot is, how many multiple choice questions are there going to be? How many code writing questions are there going to be? For starters, I don't know. I haven't finished writing the exam yet, so I couldn't tell you even if I wanted to. But also, I don't want to because I don't see myself as testing you over your ability to answer computer science multiple choice questions. I see you as I'm testing your ability to answer computer science questions, period, right? So how many multiple choice questions to me is not relevant. How many writing questions, code reading, code writing questions to me is not relevant. Will they be on the exam? Yes. Will you be expected to write code on the exam? Yes. If you know how to write code well, I imagine you'll also do well on the multiple choice problems. And this also, is a reflection of what's expected of you. I have never once, in any tech interview I've ever been a part of, been asked how many multiple choice questions I answered on my computer science exam. It has never been a question anybody's asked me. So I understand people get stressed because they don't know. That's part of life. There's always going to be unknowns in life. One of the unknowns you're going to have in life is you don't know how many multiple choice questions are going to be on this exam until you show up and take it. But if you prep and you practice and you understand computer science, I'm not afraid of any comp sci multiple question on these topics that you could ask me. I'm not afraid of any comp sci written questions, code reading questions that you could ask me because I feel like I know computer science really, really well. So the type of question ultimately should not matter. That's what I'm trying to claim anyway. You're allowed to feel differently, but I get to write the exam and give you the exam. So I'm just letting you know that that's what's happening. And I think that, one other thing I want to point out about the exam in terms of just kind of general testing strategy, especially on the code writing problems, lots of partial credit is available. Not so much on the multiple choice fill in the blanks. Those are usually all or nothing style questions, but on the code reading and the code writing questions, definitely partial credit available. So please, 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 please do not leave something blank. I want to give you points. I want to give you as much credit as I possibly can. If you leave it blank, I really have no choice but to give you 0 on that problem. There's nothing else I can do. If you give me something, anything that is hopefully relevant to the problem, I will try to give you as many points as I possibly can, I promise. So please keep that in mind. Anything that you can put down as an answer to a problem, even if it's not complete, will get some credit. So definitely make sure you're putting down something for every single question on the exam. I think that wraps up my little speech about what's coming up on the exam. Before we do some review questions, we're going to spend the rest of the time coding and answering questions and things like that. But before we do that, are there any questions about the logistics of the exam, about where to go, when to be there, things of that nature before we actually talk about the coding concepts themselves? Any questions I can answer about the upcoming exam? I'm not seeing any hands, so I take that to mean that everybody is good to go as far as where to go and when to be there and stuff like that. So for the remaining, hour and 10 minutes or so, I want to go through as many review problems as I possibly can. And I'll answer any questions that you would like me to. I'm happy to go through stuff from the big practice quiz, multiple choice style of questions. Most often, students want to see me go through some of these code reading and code writing problems. So, we don't have to do those. That's just typically what students usually ask me for. I would prefer to take suggestions from the crowd. So if anybody has suggestions of a problem they would like for me to walk through, now would be the time. Otherwise, I'm happy to just kind of pick some and go. Yeah. Question number 12 for the code writing. I would be very happy to. This repository is available to you all, so if you haven't loaded it up already, now might be a good time to get it loaded up and kind of practice along with me. Okay. Question number 12. Not surprised to be asked to do one that has to do with two-dimensional arrays. Very happy to review some 2D array concepts. We want to write a program that's going to compute the sum of all columns of a two-dimensional array. So we're going to create a one-dimensional array. This is a one-dimensional array, right? That contains the sums of the columns. So 1 plus 4 gets me the 5, 2 plus 5 gets me the 7, and 3 plus 6 gets me the 9, right? I think it's important to understand that for problems like this, and for basically any problem that I ask you on this exam, however, I will give you an example, but I want your code to work not just for this specific example, right? If I give you a second array that is bigger or smaller, I would still want your code to work. And so I kind of try to make that point, with this sentence. It should work regardless of the size of the array or the values that it contains. And so to really drive that point home, right, this is the same 2D array that's given to you as an example. On the exam, it would show up like this. Oops, not like that. Just trying to do, come on now, Eclipse, what are you doing? It's, okay. There we go. On the exam, I'm not going to give you any numbers inside of those brackets. I'm just going to have ... and you're just going to assume that those are valid values. How many? I don't know. It should work regardless. It should work regardless of what those values are. Sometimes I do say that you can make assumptions about the size of the array in the problem write-up, but in this case, there are no such assumptions. It can be any size two-dimensional array. We want our code to work. In practice, what that means is that once you actually get yourself a working solution, you probably should try it on a few different arrays and make sure your code still works properly. But let's get it working for this array, and then we can make sure that it works for all the arrays in just a little bit. First up, I think the first step that I need to do is to make this one-dimensional array. So I need to make the one-dimensional array that has the appropriate number of values in it. in order to, and we know the type of this, right? It's going to be an int array. So I'm going to make an int array. We can call it whatever we want. I'll call mine sums, right? What comes after the equal sign when I'm making new arrays? New, that's right. New int. And then inside of the brackets, we have to put the size. Can I say 3 here? What do we think? I can. Are you going to get full credit on the problem if you say 3 there? No, you will not. No, you will not. There happen to be 3 columns in this example, but remember, I want the code to work regardless of how big the array is. So how can I edit this code, right? 3 represents the number of columns. So really what I want to go inside of these brackets is the number of columns that I have in this 2-dimensional array. How do I get that out? How do I ask this array how many columns it has? Does anybody remember? Yeah. Yeah, data at 0.length is how I would say that out loud. It's slightly added on a little bit more. But yes, absolutely correct. This tells me the number of columns. And again, just to kind of remember how it gets there, right? I'm saying take the 0th row, the first row in the array, and tell me how long that row is. The length of the row should be the number of columns. If I wanted the number of rows instead, I don't, but if I did, I would just take that off. This tells me the number of rows within a 2-dimensional array. But it's up to you, especially on the exam, to determine which of those values you need. In this case, we need the number of columns. I want 1 entry in this array for each column. All right. Now that we're done with making this new array to hold our answer, we need to do the actual addition. So I need to visit each one of these elements in this 2-dimensional array and make sure to add it up appropriately. And that phrase that I said, I want to visit each one of these elements, we have a name for that. That's an array traversal. And if I'm trying to do a 2D array traversal, I want the red flashing lights to go off in your brain and think, oh, this is that nested for loop thing, right, that we went through in class last week and have probably, hopefully, seen a couple of times since then, either on the homework or the studio or both, perhaps. But yes, this is, in fact, an appropriate time for us to use the nested for loop structure that was covered when we discussed arrays. So to refresh your memory on that, we'll have one loop that goes through the rows. So I'll say I is less than the number of rows. Within that loop, I'll have another loop, a nested loop, a loop within a loop, that is going to take care of the columns. Oops. Here's that data at 0.length value again to represent the number of columns. Notice that each of these values is starting at 0. That's because we count starting from 0 when we use arrays in our code. How am I going to access, like if I want to access a value from here, right? What do I need to put to grab a value out of this array? How do I grab this 1 or this 2 out? First thing I type is the name of the array, and because it's a 2D array, I'm going to have 2 pairs of brackets where this first set of brackets represents the row and the second one represents the column. And so that's actually what we have these loops for, right? This I loop represents the rows, this J loop represents the columns. So I'll go ahead and stick I and J in there. But what I really want to do is I want to add this. I want to add this value. Add it to what? Well, I want to put it in my sum array. But what position within my sum array do I want to, or actually what I really want to do is I want to add it, right? Plus equals, I want to add it. But what position in my sum array do I want to do here? The sum array has 1 value for each column. So I really want to make sure that when I put a value inside of here, I put the value that represents the column. That's what I'm summing up, right? I'm summing up the columns. Oh, I called it sums, plural, not sum. That was what that typo is for. And I think that's it. I think this is a solution to the problem. I think if you had written this down, this code right here, for your solution to this problem, you would have gotten full credit on this problem on this exam. I think that's it. I think that's really all there is to it. I know I'm making it sound a little bit simple and straightforward, but keeping track of these indices and where they go is kind of the important part here, right? Also notice that this is not a very long answer. I think that's something else to keep in mind. I am not going to ask you to write pages and pages and pages and pages of code on this exam. If you find yourself writing an answer that is 50 lines long on the exam, I'm not going to say that it's wrong, because there are always going to be more than one way to get to the solution, but you're definitely taking a much more indirect path than what was intended. You're using extra time to do that. And the more code you write, the more potential opportunities there are to make mistakes. So, keeping things short and sweet and simple is kind of the idea. If you find yourself writing boatloads of code for an answer, you probably took a wrong turn somewhere, or are making the problem more complicated than it was intended to be. Yes?
So we wouldn't have to have like a print line?
Doesn't ask for it. Nope. It says it is not necessary to print the result. Now, if you want to check and make sure that your answer works, you would have to do that, right? I can run this right now, and what's going to happen when I run it, it's going to just say nothing. I never print anything. I never print anything. So be careful, right? What's being asked of you. I didn't ask you to print. If you did print out the array, I wouldn't count it wrong. It's just extra stuff, but that's time. That's time that you used to give me something I didn't specifically ask for. But if we wanted to print it out, we would use this same nested for loop structure. In fact, I don't think there's any shame in just copying it over and then pasting it in and printing out the contents of, actually, whoops, I take that back. I'm wrong. We're not printing out a 2D array. My apologies. We're printing out a one-dimensional array called sums. So we don't need those two for loops. We just need one for loop. One dimension, one for loop. 2 dimensions, 2 for loops. Not a coincidence. But yeah, let's go ahead and print this out and make sure that it does look correct. Sums at I. Maybe I'll put a space afterwards just so they aren't all bunched together. So hopefully I would get the same answer as the example, 579, if it summed the array properly. There it is, 579. But remember, if I change this by, for example, adding on another row, so I'll add 7, 8, and 9, I want this to still work. Obviously, the numbers will be different now, but I want it to still do things properly. So if I run this again, now that I added a third row, you'll see it got me 12. That's correct. Yeah, these numbers are all summed properly. And same thing for if I add another column. Let's say I just add a whole bunch of 5s. I'm adding a fourth column to this. Same thing. I want it to work in this situation as well. Now I should get an array with 4 values in it, right? 1 for each of the 4 columns that exist. And that last column should be 5 plus 5 plus 5 should be 15. So let's run our example one more time and see. Oh, yes. Successfully picked up that 15. Again, I got there by remembering to ask for how many columns there are instead of just saying 3. Because if I just said 3 there, but there are actually 4 columns, what's going to happen? Potentially, we're going to get one of those pesky errors that I'm assuming you saw on the last homework assignment. Maybe you didn't, but it's pretty common. You're going to get one of those array index out of bounds exceptions. That's what we're trying to avoid. good use of asking for the length will prevent these index out of bounds exceptions from happening. Any questions on this problem before we go somewhere else? Any questions? Yes?
On the exams, if we don't write it in like the shortest way, like if we take a couple extra lines, is that pretty easy?
Totally okay. Yeah, absolutely fine. Yep. You can, as I was trying to say before, you know, long answers aren't necessarily wrong. They can be right if you do them properly. But I am never going to ask you for pages and pages of code for a problem. Any other questions? Yeah.
Could you explain line 37?
Line 37. Okay. So I'm extracting this out of my two-dimensional array and I'm adding it into my sums array. I'm actually taking advantage of the fact that when I create an empty array of ints, it starts out, I say empty, but it's actually full of zeros. So the first time through this loop, we could actually run this through the debugger and see. I think that's another useful thing to be able to do. Run this through the debugger and see exactly what's getting added when, right? So the first time through the loop, the nested for loops, I hit here, I is 0 and j is 0. That's going to pull 0, 0. So there's the 1. And if I look at my sums array right now, it is in fact full of all zeros. But as soon as I start stepping through this code, there's the 1 that got added. All right, now I'm at I 0, j is 2, or I'm sorry, j is 1 rather. So it's going to take this 2 and add it here. So the first row, right, it's basically copying the first row into my sums array. That's the first pass through. But then we've finished the first row. We're now ready to move down to the second row. I is incremented to 1. So now we're going to travel down that row and add all of those values into the sum array. So if we take a look at the first value, we're actually going to get the 4 is the first value in that row. It's going to add the 4 into the sums array. And that gets us to be 5. There we can see the result of that addition. Same thing for the other 3 values in that row. And then we go down and we do it one more time. Since we have 3 rows, we spit out, or I'm sorry, we add up the last 4 values from the last 4 rows. And we can actually see there's our final result before it gets printed out right there in the debugger. Now, I almost always do my nested for loops this way. But some people say, oh, you want me to add up the columns? I want to do the columns loop first and then do the rows array second. You can do that. That is a possible thing that you can do. You just have to make sure you're using those values correctly. Might want to try rewriting this with those loops specified in a different order and see how that affects the rest of the code, how that affects the execution. But you can definitely get there that way as well. Any other questions on this problem before we take a look at another one? Any more questions? Somebody have another one they want to see me do? Any more suggestions for practice problems? Yes?
This is another 2D array.
Sure.
Question 8.
Question 8 for the code writing, I assume you mean? Okay, great. Another 2D array problem. That's not an issue with me at all. I mean, that's pretty common. This is one of the more tricky concepts that are going to be on the exam, so I'm not surprised to be asked a lot of 2D array questions. This one we want to do transposition. So for those of you who haven't taken linear algebra or matrix algebra, or maybe it's been a little while, transposition is simply the act of taking the rows of a 2D array and turning them into the columns. So the first row becomes the first column. The second row becomes the second column. So I'm just trying to do I'm trying to basically rotate. Rotate is not quite the right word. That's why we use transpose instead of rotate, right? It is in fact a transposition of the rows to the columns. And it's the same story. You can see I gave you the same, the same example array, but it should work for any of them. All right. Actually, this follows a kind of a similar process to the last problem we did. There are some differences, of course. We're trying to do something a little bit different, but a lot of it's going to be somewhat similar, including we have to start by making an array to hold the transpose, to hold our answer. So I'll call it transpose. And for the number of rows and columns, so I'm taking all of the rows and I'm turning them into columns, and then all of the columns are turning into rows. So this array is going to have, 3 rows because the original had 3 columns, and this array is going to have 2 columns because the original had 2 rows. So this is another instance where we need to ask our original 2D array how many rows and columns that it has, but we need to swap it. I need to put the number of columns here, since that's how many rows my result will have, and I need to put the number of rows here, since that's how many columns my result will have. Does that make sense to everyone so far? Okay, and now there's really kind of 2 ways you can go from here. We need to traverse one of these 2 arrays, and you can actually get there by doing either one. I can get there by traversing this array and copying the values over, or I can get there by traversing this array and copying the values over. They're 2 slightly different ways of getting you to the same place. I'm just going to stick with this one, and I'm going to use that same nested for loop structure. In fact, do I still have it? Oh no, I don't have it in my buffer anymore, so I have to either recopy it or type it out. Oh, that's not the right word. There we go. And I forgot to put that in there. There we go. That's the proper for loop for the rows. And then we'll do a similar one for the columns. Okay. And this is where the actual transposition is going to happen. I need to take a value out of this array, and I need to put it into this array. But it's really the indices that I need to be careful with, right? So this loop represents the rows for this array, but actually the columns for this one, right? Since I'm transposing. And the same is true for this other loop, right? This loop represents the columns of the data array, but the rows for the array that we're transposing. So I want to say take a value from the data array and put it in the transpose array. We just have to decide which indices go inside of these square brackets here. The right side is going to be ij, but the columns and rows are switching, so on the left-hand side we're going to say ji. I think that's it. I think this is the solution to this problem. I haven't verified if it worked yet. I can do that by printing out the matrix, which I will do in just a moment, but this one does not ask you to print out the 2D array. So as far as the exam is concerned, this is a solution. There are others, but this is a very workable solution. But let's verify it real quick and just make sure. I'll iterate not through the data one. I'll traverse the transposed one down here at the bottom, just to make sure that it's actually getting transposed properly. Oh, it's transposed without the D on there. That's the typo. Take that D off. Oops, there we go. Let's run this and make sure that we actually have an array that looks proper. And okay, I mean, these numbers look right, but they're not in the right shape, right? They're not in that rectangular shape. That has to do actually not with the array, but more to do with how I decided to display that array. We talked about this in class. I can't remember if it was last week or the week before. Remember that if we want to print out things that look like the array, we don't actually use println until we're at the end of the row. And because this loop represents the current row, we actually just want to use print inside, and then after the inner loop is over, we can put in a println statement to move us down to the next row in preparation for printing it out. Let's try that again now and see if we get something a little bit more. Okay, yeah, they're kind of smashed together. It's not 14, 25, 36. I can insert a space if I want to, just to make it look a little cleaner. And then we'll finally see. All right, cool. That looks just like the example. And just like before, if I add another row or another column or both, or I take away a row or I take away a column or both, my code should still work. So I added another row and the transpose still worked. And I can add another row and the transpose, I can add this row a bunch of times and the transpose should still work, right? Should still be able to convert it over. But let me refocus us back on the task at hand. This is the solution to the problem. Are there any questions about this problem? Any questions about what I've done? Anything I've talked about before I move on to another one? Not seeing any questions. Does anybody have another problem they'd like to see me work through? Anybody got another recommendation for me, another suggestion for me? Happy to take. Yeah, go ahead.
Number 1 on this.
Number 1, sure, let's do it. All right, triangular arrays, cool. Yeah, so here we can see this is an example of a triangular array where everything on the diagonal and above is a 1 and everything below the diagonal is a 0. So we want to provide code that's going to create an n by n upper triangular array with all non-zero elements initialized to be 1. We're asking the user for the value of n. So if they type in 7, I need a 7 by 7 array. It's always going to be square though. Triangular arrays, at least for the purposes of this problem, always going to be square. So that is a safe assumption that you can make. The first thing to do is to make our 2D array. So the user is going to tell us how big they want the array to be. I've already gone through this a few times, so I'm not going to spend a ton of time talking about it again. We're going to make a new int, and this time what goes inside of the brackets, well, it's whatever they told us. Actually, a little bit of a side note while I'm on this problem. This is our first problem that uses the scanner. Here's another thing that I want to make sure you're aware of. If you need the scanner on the exam, I will give it to you. I will provide you this code to set it up. You may have to do this part. I might expect you to do that part, right? I think that's fair game based on what we've done in this class. But this part will almost always be given to you. Or another way to think about that, you should never put this down as part of your answer on the exam. This will always be wrong if you include it as part of your answer on the exam. Always. If you need it, I will give it to you. If you don't need it, I won't give it to you. Please don't put it in. Sometimes people will assume that I want scanner on a problem. Don't make that assumption. If it doesn't say input from the user, if it doesn't say use the scanner, then don't do it. Don't use the scanner. You're just making it more complicated than it needs to be. Yeah, all right, back to the problem at hand. We got our scanner set up. They type in whatever value they want, and we're going to take that value and use it as the number of rows and columns. We're making a square array here, right? Now, we don't necessarily need to visit every value here, right? I don't need to visit every single value in the 2D array. However, I think you would find it a little tricky to write a loop that's only going to go to the upper triangle part. I suppose you could probably pull it off, actually, now that I think about it. But yeah, actually, now that I think about it, you probably could pull that off. But I think it's also very doable to just use the same, surprise, surprise, the same nested for loop structure that I've already used on the previous two problems is also very relevant here. And actually, in this case, you have the added advantage to where I can just say n if I want to here. I think that's totally fine. I don't think there's anything wrong with that at all. If you want to say triangle.length, then also fine. Don't have a problem with that. But we know that this is how big our array is, so you can save a little bit of effort by using n there. Oops. So the way I've written this is going to visit each and every element, but keep in mind that they start out at 0. So when I create this array, it wanted doubles, didn't it? Well, it kind of implies doubles, but I don't think it needs to. I don't think it matters. Whether it's a double or an int, really don't think it matters. But keep in mind that these zeros are already here. When I create an empty array, those zeros are already there. So I actually don't need to say those. All I really need to say are the ones. So the question is, how do I know when I'm in a spot that should be 1? I think the diagonal is pretty easy to figure out. What's true if I'm on the diagonal? How do I know when I'm on the diagonal? What must be true about my indices? Yeah, in the back. I equals j. So if I is equal to j, I'm on the diagonal. That's part of it, but what about this upper stuff? What's true if I'm up here in terms of I and j? So on this example, I'm at I is equal to 1 and j is equal to 0, 1, 2, 3. So this is 1, 3. This is 1, 4. This is 0, 3. Right? What's true for all of these values up here? I is, yeah, less than j. That's right. Less than j. For all the values above the diagonal, I is less than j. If we want to combine those two together, I would say that I need to put a 1 in if I is less than or equal to j, right? If I is less than or equal to j, I need to stick a, oh, what I said just sounded a lot like code, didn't it? We have to figure out how to actually turn it into code. If I, notice I'm not saying triangle at I, right? Be careful. I'm not saying the data in the array matters. I'm saying the position, the index matters. I'm trying to figure out where I am. Right? I'm trying to figure out what position I'm in. If I is less than or equal to j, then I'm going to put a 1 at that spot. If I is greater than j, I am, oops, I need to finish this statement. I'm going to put a 1 at that spot. If I is greater than j, I don't need to do anything. You don't need an else here. It's not required. However, if you decide to put it in and say, all right, if I is greater than j, the answer is 0, not wrong. Just redundant. Just extra. Not required, but we'll still definitely get you there. I'm going to take this else out. It kind of bothers me to have it in, to be perfectly honest with you. But otherwise, yeah, I think that's it. I think that's the solution. Do you have a question?
Oh, I was just going to say, if you replace the j equaling 0 with I, you can skip the estimate.
Yeah, that's kind of what I was thinking before, actually. Before I started writing this out, I was trying to figure out if I could make it even simpler. I think you're right. If I start j at I, think about what this means. For j to start at I, now I know that j is never going to be less than I. It'll only ever be equal to I or greater. I can now get rid of this if statement entirely and just leave it at this. This is not a full traversal, though. This is actually an example of only visiting the uppermost triangle. But the way I had it up here before is also good. With the if statement, I don't think there's a problem with that at all. That was actually my first inclination on how to solve it, was with the if statement. I think this is a nice little optimization, but for the exam, I would happily accept either answer. Let's prove it, too, to make sure that it actually is working properly. Just real quick, print out the contents. We already talked about how to print out 2D arrays, so I'll print out triangle at I, J, oops, and I'll put a space in between those numbers so we can see them. And then after the row is over, just do a simple print line. All right, let's give it a whirl and see if we actually are doing this properly. Let's just start with a smaller example like 5. Oh, beautiful. Pretty. Let's try a bigger example. Let's try 25. Oh, wow. But hey, yeah, it works. It works. And if you want to, you can even try bigger examples like 250, but like, oh wow, that's a lot. Oh no, that's actually too much. I can't scroll all the way to the top. It cut off. I don't know how many lines it'll print before it doesn't save, but apparently fewer than 250. I can't scroll all the way to the top. Whoops. I think it's still working. This is just a printing limitation. But as far as the actual answer goes to this problem, it's this guy right here. That's it. That's the solution. Any questions about this problem before we take a look at some other ones? Anybody have any questions? Okay. Any other problems you would like to see me work through? I've definitely got time to do some more. Yeah.
Could you go over
Number
number 9?
9.
I was like a little bit unsure of like what it was asking.
All right. The code below asks for 2 positive integers. Your task is to generate quantity random integers between 1 and 100. So it's asking you for a quantity. I'm going to generate however many they say, numbers between 1 and 100. We're then going to count the number of times that these random values are above the given threshold. So if the threshold is 50, I would expect roughly half of the numbers to be above 50 and half to be below. If it was 75, I would expect roughly 25% of the numbers, random numbers that are generated, to be above 75, right? Assuming I do it properly. And then we're going to count how many times it appears above that threshold and print it out. So, and also, I state some assumptions here that say you can assume that they're going to type in good values for the quantity and the threshold, meaning they're not going to give you negatives for these or weird values like that. But let's try it out. First thing we need to do is generate quantity random numbers. So if this is 100, I want to generate 100 random numbers. If they type in 1,000, I want to generate 1,000 random numbers. Either way, I'm doing some repetition, so I hope your brain is thinking, this is a loop, this is a loop, this is a loop, this is a loop. I think a for loop would work really well. We've been writing for loops all day, so if you're getting tired of that and you want to use a while loop instead, cool. I don't have a problem with that either. I think definitely doable with a while loop. For loop I think is going to work a little bit better. I is less than quantity I plus plus. There we go. There's a loop that's going to iterate quantity times. Now we need to generate a random value between 0 and 100 inclusive. We talked a little bit about this, I believe, just the last class, how to generate random values between 2 numbers within a given range, right? So just to kind of review, I'll make a random int, and I'm going to use math.random. But math.random only gives me a value between 0 and 1, and it doesn't include 1. So 0 inclusive, 1 exclusive. That's not what we want. We want numbers between 1 and 100. We also don't want doubles. We want integers. So there were 2 things that I needed to do to make sure these values are within the appropriate range. The first was to scale. I need to scale up by the total range. And then we also need to add to shift the whole range to start at the appropriate place. So I don't want it to start at 0. I want it to start at 1. I want it to start at 1. And you can do a quick little sanity check here, right? If I get 0, 0 times 100 is 0, and then there's my 1. Comes back out on the low end. If I get 0.9999999, which is the largest thing I can get, I'm going to have almost 100. If I add 1 to that, that's going to be 100 point something, 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 something. And then when I do the last part of the problem, which is to cast it to an int, then that will take care of chopping off the decimal place so that we get our values in the appropriate range. By tweaking these two numbers here, we can generate random numbers between any two values that we want. Okay, back to solving the problem at hand. We just want to see if this random value that we generate is above this threshold. So I'll go ahead and say, if random is greater than threshold, then I need to keep track of that somehow. I want to see how many times this happens. I need to count. That means I probably need a variable to keep track of this count. So, all right, I'll start the count at 0. If the random number is above the threshold, I'll say count plus plus. And by the time this loop is finished, we should have our proper count. It wants us to print the total random, so print the count as well as the percentage, which is just a little bit more arithmetic to do. To print the count, that's very easy. We can just print the count directly. To print the percentage, we have to do a little bit of math. I want to take the count and divide it by the total number of random values, which is the quantity. However, I think if we run this, we'll see that there's a little bit of an issue with the way that I did this. Let's try it out. I want to do 10, and the threshold will be 50. Oh, shoot. It says that it was above the threshold 5 times, and that's 0%. Whoops, that doesn't seem right. That should be about 50%. Why did this give me 0? So types matter. I'm doing division. The thing on the left is an int. The thing on the right, also an int. The result is going to be an int. If I think about this in terms of what the actual numbers are, this is meant to be a percentage, meaning that this value is always going to be bigger than this value. So no matter what happens, I'm going to get a 0 out. Always, 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 always. If I want to fix that, I need to turn one of these into a double. There's a few different ways you can pull that off. Some people would come up here and put a double here. I actually kind of don't like that as much, but it would work. I wouldn't count it off on the exam. What I might prefer to do instead would be to multiply this by 100.0, which also has the effect of shifting that decimal point a little bit and making it look more like an actual percentage, as well as converting this to a double to avoid the integer arithmetic. And if we try this example again with that little tweak, we'll do 10 random values, and the threshold is 5. Oh, wow, all 10? Really? That almost feels like a mistake, but I guess it's possible to get that lucky. I didn't print out what the actual random values were. We'll do 100 of them this time. Oh, I typed in 5, didn't I? That's why all of them were bigger. That's what I did. Not 50, I typed in 5. That actually is a lot more realistic. I was about to go buy a lottery ticket. There we go. 38 we're over, and 30. Oh, well, 100 numbers. That makes sense. Yeah, that would be an even percentage. But anyway, I think it appears to be working. We'd have to try it with some more numbers to, really verify that it's doing things properly. Okay, 259 times it generated a value above 50, and that's 51.8% of the time. Question?
We also multiply it by a double, like instead of multiplying it by 100.0, we just multiply it by the 5, like casting.
So casting is a thing, but we don't multiply by the cast. Casting is just putting the type in parentheses out front. But yes, this is another possible solution that would work. Although be a little bit careful. I think you do need to pay attention to order of operation. Oh no, that worked, yeah. I was a little worried that maybe that wouldn't work, but yeah, it did. So what's the solution to this problem? That's it right there. Any questions on this one? Yeah.
So hypothetically, if you multiplied that percentage by like say 100,
Mm-hmm.
And you just had 100 as an integer,
Mm-hmm.
would it, like, does that revert to an integer for the next series, like the casting? Does it undo and become an integer again?
You mean if I multiplied this by 100 like this?
If you like put all that you had in parentheses and then multiplied by 100, would then?
Oh, so like at the very end,
Yeah.
I multiplied by 100. So because, let me just make sure I understand. So like this, is that what you're getting at? Yeah, this whole thing is going to be a double when it's done. So a double multiplied by an int is going to be a double.
Okay.
Yeah. Yep. Anytime I'm doing an operation with doubles and ints, I'm going to get doubles back out. Only when both are ints am I going to get an int back out. It's a good thing to be aware of, though, because that definitely will appear on the exam. And the instructions didn't say that you had to shift the decimal for the percentage either, so I think multiplying by 100, while maybe a nice thing to do, is not strictly a required part of this problem. If you left your percentage as a value between 0 and 1, I accepted that as a valid answer. Any other questions on this problem before we take a look at some more practice problems? All right, I think we have time for at least one more left. If anybody, at least one more review problem. If anybody has one that they would like for me to walk through, if anybody has any suggestions. If not, I have one in mind. Not seeing any hands, so I am going to look at, I think it's number 4. Yes, number 4. I would argue, so you've asked me a lot of 2D array questions today, and I am not surprised by that at all. Very happy to spend time reviewing 2D arrays. This is another 2D array problem. However, this one I would argue is a bit different than the other 2D array problems that we've looked at so far. So I think it's good to go through this example almost as kind of a word of warning to think carefully about the problems that you're being asked. Think very carefully about what you're being asked to do. In this problem, we're given a 2D array of integers, and we want to randomly select them. So I'm asking the user, how many random points do you want to pull? If they type in 3, then I want to pick, what, the 3. I might randomly pick the 3, might randomly pick the 6, and then I might randomly pick the 3 again. There's nothing saying that I can't randomly pick the same point more than once in this particular example. And then I want to take those and I want to put them into this points array, which I was very, I think, somewhat generous on this problem, and I even gave you the line of code to create the points array, just so there would be no confusion. I want to randomly select n points out of this 2D array and put them into this one-dimensional array. So every other 2D array problem that we've seen today, I started out by saying, this looks like a prime example for 2D array traversal. I'm going to bust out those nested loop structures. But notice that the problem this time just says I'm going to pick n random points. So I'm going to pick the 2, I'm going to pick the 4, and I'm going to pick the 3. Do I need to visit each and every one of these elements? Am I going to visit each and every one of these elements? No. No. I am picking these elements at random. So it's possible that I won't look at any, there's some of these values that I may never randomly select, right? I'm not traversing in a particular order. I want to pick things out at random. So the 2-loop structure, the nested loop structure, actually is not the appropriate way to go on this problem. I am not traversing this 2D array, so I don't need the 2-dimensional nested for-loop structure. Instead, what I'm doing is I am generating n random values. I'm extracting n random values from this 2-dimensional array. So the repetition is based on n and only n. I don't need 2 loops. I just need 1. I just need 1 for this problem. Yes, I'm using a 2-dimensional array, but based on what the problem's asking me to do, I don't need to traverse the 2D array. I just need a loop that's going to go n times so that I can pull n values out of this 2D array. So, okay, let's write a loop that runs n times. There we go. And now I need to select random points out of this array. In order to pull, let's say I want to randomly select this 3. I need 2 pieces of information to get to that 3. I need a random row, and I need a random column. So what I'm really asking for inside of this for loop is to generate a random number between 0 and the number of rows, and then generate another number between 0 and the number of columns. And those 2 values are what I'm going to use to grab my random value out of the array. So we actually need to generate 2 random numbers here. I'll call the first one row. And how do I make sure that I'm going to generate a random value that is in the appropriate range for the number of rows? Well, it's not like it's just like any other random values that we would generate. I'm going to multiply by the range, where the range in this case is the number of rows. So think about it. If this is 0, and I multiply by the number of rows, then I'm going to get 0. And that's actually good. 0 is the first index, right? I want 0 as a possibility. If this gives me 0.9999999 repeating, and I multiply this by the number of rows, which in this case is 2, let's just use 2 as a simple example, that would give me 1.99999. But then I am going to recognize the fact that, well, index isn't going to have a decimal, right? Index has to be an int. In fact, I already said that here. So just like we saw in the previous example, I need to cast to an int. So that 1.99999 is going to become 1, which, recall from our conversations of arrays, if there are, n rows, the index of the last one is n minus 1. So if there are 2 rows, the index of the last one is 1 less than that. This works. Because math.random will never give me 1, it'll only give me 0.9999999, this will always give me values between 0 and up to, but not including the length, the number of rows of my array. And similarly, we're going to have a very similar statement for the columns. Except we're going to multiply not by the number of rows, but by the number of columns. And we're almost done. The last thing that we need to do is extract the value at this position out and put it into this points array. So our points array at position I is going to be equal to our data array at the random row and random column that we generated. I think this is it. I think that's the solution right there to this particular problem. No nested for loop necessary. So while yes, 2D arrays and nested for loops do go very well together, it's not a guarantee that that's what you need. Pay attention to what the problem's asking you. Use your critical thinking skills to decide which constructs you need. Your answer needs to match what's being requested of you. Now, I do think there is a mistake in here. Does anybody see a problem with what I've written? There is one thing that I think is a bug, a mistake. Anybody know what it is? We can test it out to see what the problem is by, even though it wasn't asked for, I can iterate through the points array and print out the contents and see if it actually is doing what we want it to. So let's do that real quick. How many random points would I like? Let's just do 5. Oh. Okay. 1, 1, 1, 1, 1. So I got all ones. Technically possible, right? Technically possible that I could randomly select the same number 5 times in a row, but let's try, I don't know, 25 random points out of here, right? Oh boy, yeah. All right. That's not me being extremely lucky. That's a problem. It's always picking 1. Well, let's think about that for a second. Where is the 1? The 1 is the very first value. It's in position 0, 0, which means that it's picking 0, 0 every time. So that means the error is here. Yeah. Did you see?
Yeah, it's casting the math.random.
Order of operations. You got to be careful. It's doing the cast first. I'm picking a random value between 0 and 1 and then saying turn that into an integer. That's always going to be 0 every time. Always. So how do I fix it? Use parentheses to clarify. Clarify what you mean. I think that's an important one to bring up because, yes, you were all taught order of operations, right, in your algebra class, however many years ago, but casting probably wasn't on that list, I'm willing to bet, when you learned about order of operations. Well, it's an operation now, and so is ands and ors and greater than and less than. Those also have an order of operations that they are going to fit in as well. Be sure to refresh your memory on those things before the exam if you need to. Put them on your cheat sheet if you need to. Let's try again and make sure this is actually doing, a more appropriate thing. Here we go. 3, 4, 2. Yeah, and there we go. We got random values. The 2 showed up more than once, but that's okay. If we were doing this as an experiment, right, I would say this is a random selection with replacement. A random sample with replacement. However, I didn't ask you this question here, but I'm going to ask it to you now. There was a follow-up question to this on this exam that said, in the previous exam, or on the previous problem, we had you do random sampling with replacement. What if I didn't want to select the same random value more than once? What if I didn't want to allow the same value to appear in my results more than once? How would that change the code? Can anybody think of what we would need to do to make sure that I didn't pick the same value randomly more than once? Does anybody have any ideas on what we could do? Just in English. You don't need to tell me the code or anything. Just in English. What could I do to avoid picking the same value more than once? It's actually a little bit tricky. It's a little bit trickier than it might seem, because if 2 appears more than once, then I can pick it, twice, right? But I couldn't pick it 3 times, for example. So really, what's limiting us isn't I was a little bit misspeaking before. It wasn't the value that can't be selected more than once. It's the position that can't be selected more than once. So I can't have the same combination of row and column more than once. I can think of 2 ways to accomplish this. They both require at least one additional array. But the strategy for both is kind of the same. I need to remember the positions of the values that I've already selected. So I either need to write down the row and column numbers that I've selected. After I pick a value at a certain row and column, I need to write those numbers down. I need to put them into a second array. And remember that I've already picked these. And then the next time I randomly generate, if I pick the same combination that I've already picked, I need to say, whoop, I already did that one. Let me pick a new one until I get one that I haven't picked, right? That's one solution. Or actually another solution, which I tend to like a little bit better, is to make a second 2-dimensional array. So I would actually make a Boolean 2-dimensional array. And every time I pick a new row and column, yes, I'll randomly extract the value out, but I'll also go to my 2D Boolean array and mark that position as being true, meaning I've already selected it, right? So the next time I generate a row and a column, I'm going to look at this Boolean array and say, hey, if it's marked true, that means I've already grabbed the value at that position. I'm going to randomly generate a new position and keep doing that until my array tells me false, meaning I haven't selected that position before. But either way, I think you need an array. I either need an integer array to write down the actual coordinates that I've already selected, or I need a Boolean array to track the coordinates that I've already selected. I think either approach would work. There's probably even a third answer or an infinite number of answers that could get you there as well. But I like both of those answers for this problem. As far as what was asked, though, this is the solution right here. That's it. Were there any questions about this particular problem? Any questions? Yes?
What's a close?
Oh, yeah. So this is for the scanner. I put this in. I started trying to put it in simply because if you don't, it will complain sometimes about it. Although, oh yeah, here. It complains. You may have noticed this. It's highlighted in yellow. Resource leak in is never closed. But by putting that in, it gets rid of that problem. Doesn't actually break anything. Would not expect you to put that on the exam. It's not going to be covered on the exam. Just me trying to clean up a little bit better. Be a little bit more intentional about my code. Good question, though. What does closing it do? Well, yeah, that's a good question. Every time you create this, you're spending resources on the scanner. So when I don't close it, I'm saying that there's a potential that I might actually use this scanner again. By closing it, I'm saying I am done with the scanner. You can throw it away and use whatever resources you are using on other stuff now. So it's potentially wasting resources, which for our purposes, these programs are so small, not going to make a difference. But if you're working on a big program, could potentially make a big difference. Yeah, good questions. None of that will be on the exam, by the way, but happy to answer those kinds of questions. Any other questions I can address about this problem? Or any other questions I can address in general? I don't think I have enough time to go through another practice problem with the 7 minutes that I have, but I will stick around if you have any more questions. There's also another review session right after this one, so I'll probably do a lot of the same problems, but if you want to stick around and do some more review, you are more than welcome to do so. Otherwise, I will see you either in the labs on Wednesday or at the exam on Thursday. Have a good rest of your day, everyone.